In this video, I'm going to discuss how you can use a straight edge and a device called a compass to construct some of the special types of lines, segments, and other figures that we talk about in geometry. A compass is a device that looks something like this, and a straight edge is usually just a ruler. However, we won't use the markings on the ruler. We're just going to use the fact that it helps us get good straight lines and segments. It's important to note that all of the special lines, segments, and other figures I'm going to talk about can be constructed using a protractor and a ruler. But in this video, I'm going to discuss how you can construct these special lines, segments, and other figures without measuring anything. Here's a list of the topics I'm going to discuss along with the time in the video that I discussed them so that you can fast forward to the topics that interest you. You should note that you can see the time by moving your mouse over the video while you are watching it. Before you watch the rest of this video, please print the document at the website you see here and have it in front of you while you watch the remainder of the video. The first 10 pages of this document contain practice problems on each of the topics I'm going to discuss. The rest of the document contains written instructions that tell you how to construct the special lines, segments, and other figures. You should see that these pages show you how to work the first problem on each of the practice pages. You should also note that the instructions are color-coded and that the color of the step corresponds to the color in the picture. In this video, I'm going to work the second problem on each of the practice pages so that you will have two examples to go with each concept. Now, let's look at our first construction. When a question asks you to copy a segment, it wants you to draw a new segment that has the same length as the old one. To do this, I'm going to start by drawing an initial ray. And now I'm going to place the compass point on one of the endpoints of the original segment, and I'm going to open the compass so that the width of the opening matches the length of the segment. I'm going to place the compass point on the endpoint of my new ray, and then make an arc that intersects my initial ray. And now this segment will have the same length as the original segment. For my next construction, I'm going to show you how to copy an angle. When a question asks you to copy an angle, that means that it wants you to construct an angle that is congruent to the given angle. We'll start by drawing an initial ray, and I'm going to label the endpoint of the ray point X. Next, I'm going to place the compass point at the vertex of my original angle and make an arc that intersects both sides of the angle. And I'm going to label the points where this arc intersects the sides of the angle points A and B. Next, without changing the opening of the compass, I'm going to place the compass point at the end point of the ray from step 1, and then I'm going to make an arc. I'm going to label the point where this arc intersects the ray from step 1, point Y. Now I'm going to place the compass point on point A and open the compass so that the pencil touches point B. And now, without changing the width of the opening of the compass, I'm going to place the compass point on point Y and make an arc that intersects the arc that I made in step 3. And I'm going to label the point where these two arcs intersect, point Z. And finally, I'm going to draw ray XZ. If you're using my geometry book as your textbook, you probably know that I do not want you to trust me when I say that a statement is true. I would prefer for you to be able to prove that these two angles are actually congruent to each other instead of trusting me when I say that they are congruent. The proof that these two angles are congruent uses some of the concepts I discuss in parts 3 and 4 of chapter 4. If you have already done this chapter, please pause the video and take a look at the proof on page 13 of the handout I told you to print earlier. If you have not finished these sections yet, please come back to this video and look at the proof after you have done these sections. The proofs that the constructions that I discuss on pages 14 through 18 of the handout produce the figures that I say they do also use concepts from Chapter 4, and after you have finished Chapter 4, I encourage you to try to prove on your own that the sets of steps I give in this handout will always produce the figures that I say they will. The proofs that the constructions I discuss on pages 19 through 21 of the handout produce the figures that I say they do involve concepts from chapters 6 and 9 of my geometry book, and I encourage you to try to prove that these steps will always produce the figures that I say they will after you have completed Chapter 9. For my next construction, I'm going to show you how to draw a bisector of an angle. And you should know that that means that we're going to draw a segment or array that divides our angle into two congruent smaller angles. I'm going to start by placing the compass point on the vertex of my angle, and I'm going to draw an arc that intersects both sides of the angle. I'm going to label the points where this arc intersects the side of the angle points A and B. And now I'm going to open the compass so that the width of the opening is more than half the width of the angle. And now I'm going to place the compass point on point A, and I'm going to make an arc in the interior of my angle. Next, I'm going to place the compass point on point B, and I'm going to make an arc that intersects the arc from the last step. I'm going to label the point where this arc intersects my last arc, point C. And now I'm going to construct my angle bisector by drawing a ray that connects the vertex of my angle and point C. We can also draw a bisector of an angle using paper folding. To use this technique, I'm going to fold the paper so that the two sides of the angle lie on top of each other, and then I'm going to make a crease in the paper. And I must, of course, make sure that my crease passes through the vertex. And now I can draw the angle bisector by following the fold in the paper. For my next construction, I'm going to show you how you can construct a perpendicular bisector of a segment. You should know that this means that I'm going to draw a line, segment, or ray that intersects the given segment at its midpoint and forms 90-degree angles with the segment. Since the perpendicular bisector of a segment passes through the midpoint of the segment, you should realize that you can also use this set of steps to find the midpoint of a given segment. I'm going to start by opening the compass so that the width of the compass is more than half the length of the segment. Next, I'm going to place the compass point at one of the endpoints of the segment, and I'm going to make arcs above and below the segment. Now I'm going to place the compass point at the other endpoint of the segment, and I'm going to make arcs above and below the segment again. I'm going to label the points where these arcs intersect the arcs from the last step, points A and B. And now I can construct my perpendicular bisector by drawing a line, segment, or ray that connects points A and B. We can also draw a perpendicular bisector of a segment by using paper folding. To use this technique, fold the paper so that the two halves of the segment perfectly overlap each other. The two endpoints must line up perfectly. After you get the two halves to line up perfectly, place a crease in the paper. Then draw your perpendicular bisector by following the crease in your paper. For my next construction, I'm going to show you how you can construct a line perpendicular to a given line that passes through a given point on the line. I'm going to begin by placing the compass point on my given point, and I'm going to make arcs that intersect the line on both sides of the point. I'm going to label the points where these arcs intersect the line points A and B. Now I'm going to open the compass so that the width of the opening is more than half the length of segment AB. Next, I'm going to place the compass point at point A, and I'm going to make arcs above and below the line. Now I'm going to place the compass point at point B, and I'm going to make arcs above and below the line again. And now I can draw my perpendicular line by connecting the points where the arcs from the last two steps intersect each other. To construct a line that passes through a specific point and is perpendicular to another line by folding the paper, you can follow a procedure similar to the one I showed you for drawing a perpendicular bisector. Once again, I will fold the paper so that the two parts of the line overlap. However, this time, I will not make sure that the endpoints line up. Instead, I will make sure that the crease in my paper passes through my given point. For my sixth construction, I'm going to show you how you can draw a line that is perpendicular to a given line and passes through a point that is not on the line. I will start by placing the compass point on my given point, and I'm going to make arcs that intersect my given line. I will label the points where these arcs intersect the line points A and B. Next, I will open the compass so that the width of the opening is more than half the length of segment AB. And now I will place the compass point on point A, and I will make an arc on the side of the line opposite the side of the line that has my given point. Now, without changing the opening of the compass, I'm going to place the compass point on point B and make an arc that intersects the arc from the last step. Finally, to draw my perpendicular line, I'm going to draw a line that connects the given point and the point where the arcs from the last two steps intersect each other. Like I demonstrated earlier when I showed you how to draw a line perpendicular to a line that passes through a point on the line, you can also use paper folding to draw the perpendicular line here. Again, make sure that the two parts of the line overlap each other and that the given point lies on the fold. For my seventh construction, I will show you how you can construct a line that is parallel to a given line and passes through a given point. I will begin by drawing a line that passes through my given point and intersects the line. This line does not have to be anything special. It just has to pass through my given point and intersect my given line. Now, since two lines are parallel if and only if their sets of corresponding angles are congruent, I'm going to follow the steps that I discussed earlier for copying an angle. I'm going to copy this angle here so that I have a congruent corresponding angle that passes through my given point. For my next construction, I will show you how you can construct a regular hexagon that is inscribed in a circle. This means that all the sides of the hexagon will be congruent to each other, all the angles of the hexagon will be congruent to each other, and the vertices of the hexagon will lie on the circle. I will start by placing the compass point on the center, and I will open the compass so that the pencil touches a point on the circle. Next, I will make an initial point on the circle. Now, without changing the width of the opening of the compass, I will place the compass point on the point from the last step, and I will make an arc that intersects the circle. Without changing the width of the opening of the compass, I'm going to place the compass point where the arc from the last step intersects the circle, and then I will make another arc that intersects the circle. I will continue this process until I have gone all the way around the circle. Finally, I can construct my hexagon by connecting the points where the point from step 2 and the arcs from step 3 and 4 intersect the circle. For my ninth construction, I will show you how you can construct an equilateral triangle that is inscribed in a circle. You should know that this means that all sides of the triangle will be congruent to each other, all the angles will have measures of 60 degrees, and all the vertices of the angles will lie on the circle. I will follow exactly the same set of steps that I just discussed when I showed you how to construct a regular hexagon. The only difference is that, in the end, I will connect the initial point in every other arc instead of connecting consecutive arcs. For my last construction, I am going to show you how you can construct a square that is inscribed in a circle. I will start by drawing a diameter of the circle. This does not have to be any particular diameter, but, of course, it must pass through the center of the circle. Now, I'm going to follow the steps I discussed earlier to construct the line that is the perpendicular bisector of this diameter. Finally, I can construct my square by connecting the points where the diameters intersect the circle. If you have comments or questions about this video, please feel free to contact us using the Contact Us link in our website.